Welcome to our revision class. I will begin my revision by saying don't complicate what you already know. Answer it as you know it. So certain questions are as straightforward as they appear. Don't overcomplicate them. So let me start with what all of you know. Let's start with maybe question number 1, part B. Okay, these are 3 marks. Question 1, part B. We're given this question to say the average dividend declared by a group of 12 was 18%. So at least we should know the formula for average. Average is X bar is equal to summation of X over N. So the average declared by a group of 10 companies. So this 10 stands for N, and this 18% stands for the mean. Later on, it was discovered that there was an error of commission. The correct figure, 12, was actually written as 22. So instead of 12, we wrote what? A plus 10. So we actually wrote 22. So we need to remove this 10 that was added to get the correct average. So what we're going to do is our mean was what? 18%. The sum of these 10 companies, we don't know, but we can calculate it by cross multiplying. So 18 by 10 is 180. So summation of X was giving us 180. But we've discovered that from this 10, there's one element in this 180, which was wrongly written. Instead of 12, we wrote 22. So you could either do this. You remove this 12 and add the 22, or simply add the difference there. I repeat, in this 180, we overstated it by a figure of 10. So we need to remove the 10 in there so that we get the actual total, because where there was 12, we wrote 22. So we overstated our figure by 10. So the actual mean was supposed to be, the actual total was supposed to be 170. So to get the mean, we're going to divide the 170 divided by 10. So our mean, instead of 18%, was actually 17%. So please just write the figures as they are, because put it as a percentage of 0.18, you get it. In the decimal, you need to calculate it again. So it's the same thing ultimately. So this is how we get the 17%. Are we together? Anyone behind at that point? Okay. Then we go to question part D. We are told that from an analysis, there were wages that were paid to 2 companies, company X and company Y. So we've been given the data as shown in here. The data that has been given is that the N, the number of wage earners, 550 and 650. Average means the mean for the wage earners, X bar. Here we have 5,000 and here we have 4,500. And the variance for the age earners, here we have what? 900 and here we have 1,600. And you can as well calculate the standard deviation if you want on your own. because when you square root the variance, it is called the standard deviation. Square root of 900 is 30. Square root of 1600 is 40. So for 2 marks, which of the two organizations pays a higher monthly wage? So I'll calculate for machine 1, which of the two companies pays a higher monthly wage. So to answer this, we'll go back to our formula that we just used. So what's the formula for the mean? Who remembers? What's the formula for the mean?
Summation of x over n.
Summation of x over n. Okay. So we're going to use that formula, summation of x over n, organization, mean for organization x. Summation of x over n, the mean for organization y. So in this vein, let's start with organization x, the data parameters, and calculate the one which will give us a higher numerical value. So organization x, we have our n is 550 and our mean is 5,000. So here our mean is 5,000. Summation of x we don't have. Then the n is 550.
It's a bit cold.
Okay. So when you multiply 550 by 5,000, what do we get? The value of company X. What do we get when we multiply there?
2,705,000.
I didn't get that. We can give anyone to give me the figure when you cross multiply.
It's 2,750,000.
Okay. 2 million or split them. 20 what? 2.
2,750,000.
And 750. Okay. So this is a numerical value that company X pays out. And company Y, you can use the letter Y there. Summation of Y, therefore, will be equal to n times the mean of Y. So our n for company Y, when you check in here, our n for company Y was 650 and our mean was 500. 650 and 500. So just multiply the two. 650.
2925.
500. What do we get? 2925. 2925. So which of the two companies pays more? Company X or company Y?
Company Y.
company Y. All right. So here they're just asking you to know how to calculate the value of the summation of X. So now we'll go to the next question. So how many marks for that were we given? We're given 2 marks. And they're asking you which organization has a greater variability. Which organization has a greater variability? So variability is basically the coefficient of variation. You can calculate the coefficient of variation by dividing the standard deviation divided by the mean. So let's calculate and get what we call the CV. So the CV for company X, the CV for company Y. We just divide our standard deviation divided by the mean. So 30 divided by 5,000 and 40 divided by 500. The higher the CV, the more the variability. So what are we getting?
Where did you get the 30 and the 40?
Where do we get the 30 and the 40?
It's the standard deviation for X and the other one is for Y.
By square rooted, and then
Oh, square rooted. Okay.
is that clear? So let's get the coefficient of variation. What did you get for company A? We divide 30 over 5,000. Times 100. Here you're getting 0.6%. The one that has a higher percentage has more risk. Then here we have 40 divided by 4,500 times 100. You get 0.88%. So which one has a higher variability? Company Y. It is volatile. It is risky. So the higher the CV, the more the coefficient of variation. And how did you find the CV? Simply standard deviation over the mean times 100. So this is computed to calculate the degree of variability. So I want us to gather up 50 marks scantily selected so that I show you that this is very easy to manage. Remember, most of the questions will come from these tests that we're doing. So before we get complex, you should understand what I'm discussing.
Mr. Collins, sorry to take you back on the when you find the standard deviation, I'll get for X 900 is 30. And then you came to 5,000 divided by 30 multiplied by 100.
Yes, using this formula here,
Mhm.
the standard deviation is 30 divided by the average, which is 5,000. Then multiply by 100.
No, 30 divided by 5.
So 30 divided by 5,000.
Oh, okay. I was doing 5,000 divided by 30. Okay, thank you.
All right. Any other questions? Are we together? All right. So we have gathered how many marks so far? We have gathered. We should be counting until they reach 50. Then we'll go to another topic. All right. So we're now on question number. Question number 1. Question number 1, we are told that we have a cumulative frequency table for a preferred length of kitchen slabs observed by housewives. We're given the data below. So we now need to calculate the length of the slabs that you'd recommend, 6 marks. So the following table shows the cumulative frequency distribution of preferred length of kitchen slabs obtained from the preference study of housewives. So the manufacturer has to make a decision on what length of slabs to manufacture and what length would you recommend. So the first thing is we need to understand what the question is asking for. So we are told that these ones want to make a kitchen slab and the length of meters, 50 housewives said more than 1 meter. 48 housewives says more than 1.5. 42 said more than 2 meters. 40 said 2.5. 10 said 3.0. 5 said 3.5. So to make a decision on the best length of slabs before you go to computation is firstly to accept that you're looking at the mode, because the mode stands for the what? The most frequent. So obviously for you to make a decision as a company, you need to pick on what people like the most, isn't it? So before I proceed with the computations, I need you to understand what is being asked. So let me see whether this has some working. So we're looking at the length of time that was preferred. So we need to pick on the highest mode from there. Okay, so we're going to just write it down. So we've been given our length. So before we go to the length, we can calculate the frequencies as follows. Since these are cumulative frequencies, to find the actual frequencies, we find the differences. Okay, the difference between 50 minus 48, what do we get? It is a 2. Then 48 minus 42, what do we get?
6.
6. 42 minus 40, what do we get?
2.
40 minus 10, what do we get?
30.
And finally, 10 minus 5.
5.
Okay. So we now need to go to computing the frequency distribution table. We need to compute the frequency distribution table. So we are also going to come up with a frequency, because this will be the midpoint. So we'll subtract from here a 0.5 and add a 0.5 there, so that we know the ranges we're going to work with. Are we together? We want to reconstruct a frequency distribution table, for which we need to calculate our mean and the mode, identifying the mode. So with the data that has been given here, what did we do first? How did you find these frequencies here? Can somebody answer? How did you find these frequencies here? By subtracting 50 minus 48, we get a 2. 48 minus 42, we get a 6. 42 minus 40, we get a 2. 40 minus 10, we get a 30. Then finally, 10 minus 5, we get a 5. Then we'll make our frequency distribution using the lowest figure. We'll just keep adding a 0.5 there to make sure that this becomes our so we can have the frequencies as 1. Just add a 0.5. Okay, since they make it easy for you, we can use these ranges from, so to make it a histogram. This number to that number, this number to that number, this number to that number, until we go to the last one. So we have 1.5, 1.0 to 1.5. What frequency are we going to use? 2. The next one will be 1.5.
Mr. Collins,
Yes, yes.
sorry to stop you. So is it okay to also say we subtract from, let's say 0.5 to 1, then 1.0 to 1.5? Is that also okay, or?
Yes, it's okay. It's okay where you're subtracting a 0.5 from there and adding a 0.5 to the very number. Yes, it's okay. But let me use
Right, thank you.
right here. Yeah, but you still get the same value ultimately. So I started with this one here for simplicity's sake, since we're using these ranges here. So 1 to 1.5, this is a 2. 1.5 to 2, this is a 6. Then we go to 2.0 to what? To 2.5. What do we get? A 2. Then 2.5 to 3.0. You get a what? A 30. And finally, a 3.0 to 3.5. Get our last number there as 5. So I'm going to rate this on a plain sheet. Just wanted you to know where those figures are coming from. So we have 1.0, 1.5, 1.5 to 2.0, 2.0, 2.5, 2.5, 3.0, 3.0, 3.5. Frequencies, we had 50 to 48, which gave us what? 2. 48 to 42, which gives us 6. 42 to 40, which gave us another 2. 40 to 10, which gave us the biggest number, which is 30. And finally, our 10 to 5, which gave us a 5. Okay. So we can calculate the cumulative frequency. Cumulative frequency, of course, it is not important for the calculations that we need for now. We can just go directly to calculate the mean. So the midpoint, when we add 1 plus 1.5, we get 2.5. We divide by 2, we get 1.25. 1.5 plus 2.0, when you add and divide by 2, you get 1.75. 2.0 plus 2.5, we get 2.25. Then 3 plus 2.5, we get 2.75. Finally, 3.0 plus 3.5, we get 2.35. No, 3 plus that one is 3.25. Then we apply the two columns, frequency times the x. Fx here, we get 2.5. Then here we get 10.5. Here we get 4.5. We apply 2 times 2.25, then 30 times 2.75, we get 82.5. 5 times 2.25, we get 16.25. We add up, what we get here is the summation of fx, which is 16.25. When we add the frequency column, we get our total value n, which is 45. So the first part of the question was asking us to calculate what? The mean. What is our mean? Our mean will be summation of fx over n. Okay. So 16.25.
Mr. Collins,
Yes, please. Wait, I'll ask you to
Mr. Collins,
yes, please. Yes, please. Can you hear me?
Sorry, Mr. Collins, is it supposed to be
the figure is not correct. The 161
supposed to be 116?
The total.
Supposed to be 116.
All right, okay, 116, thank you. Oh yeah. 116.25.
Summation is, yes, summation is 116.25 and not 16.25.
All right, thank you so much. Yeah, it's 116.25. So the mean, what is our mean? When you divide 42 there. What becomes a mean?
.58 meters.
Okay. So the mean should range within the mode or the model class. So the highest frequency is 30.
Divide by 45, not 42.
45.
N is
Not-
45, not 42.
5. Thank you. Am I still audible?
Yes, you are.
So the mean we calculated was 116 point what? 25 divided by our 45, which gave us 2.58, which ranged between the 2.5 to 3.0, which had a model frequency of 30. So meaning we can safely conclude that we'll recommend what? Can safely conclude, because they're asking us to make a decision on what length of slabs to manufacture. So we're looking at the average. Now, most of them came from this range where 30 is high. So to give a picture from the mode to say the average should come from these 30. So from our frequency distribution table, we're able to calculate our mean, which is 2.58. So that is how we find the mean. 6 marks for that. Okay.
Hi, Collins.
Yes, sir.
Me, I'm behind on this. The frequency. How did you arrive at it? The 235. Sorry to take you back.
Okay. The frequency I had explained to say when you're given this is a cumulative frequency, it was stated in here. So meaning these ones are adds on, they're adding on, they're cumulative. So for them to be adds on to get the actual frequency, we do the reverse way. Because when you're dealing with a class, a normal class of, for instance, you have 1 to 6 or 1 to 5, and you have 6 to 10, you have 11 to 14 to 15, you have 16 to 20. Given a frequency, for instance, of 3, 5, 7, 5. And what becomes a cumulative frequency? How do you find the cumulative frequency? Start with a 3.
Add the numbers here. 3.
You get what?
Then 8.
So we added 5 plus 3, 8. Then
15.
15. Then
20.
20. Let's work in reverse now. To find this 20, to find this 5, we subtracted what? 20 minus 15, we get a 5. 15 minus 8, we get a 7. 8 minus 3, we get a 5. Okay. So using this same format is what we did here in reverse. So here, 50 minus 45, we're starting, we get what? A 2. 48 minus 42, we get a 6. 40 minus 42, we get a 2. 40 minus 10, we get a 30. 10 minus 5, we get a 5. Is that clear?
That's clear. Thanks.
Right. Anyone who was lost at that and you've gotten it now? So using his solutions as well, just to fortify. So this is the length, and we have a 50, and the class interval, we start from this very one to the next one. So 1.0 to 1.5, 1.5 to 1.2. So we're just adding, we're getting the intervals from the length. Then the frequency, we're subtracting 50 minus 48 is 2. 48 minus 42, 2 minus 40, 40 minus 10. So these are the frequencies. So with this being done, it now nullifies the last row because there's no pair. We're going to end here. Here there'll be nothing to relate. Then we extract this now. with the class intervals we just created there. When you add 1.5 to 1 divided by 2, we get the midpoint, 1.25. We add this to 1.5 plus 2.0 divided by 2, we get this figure. 2.0 plus 2.5 divided by 2, we get this figure. So the midpoint is simply the lower bound plus the upper bound divided by 2. The frequencies are the ones that we just recalculated now. So when you multiply the midpoint times the frequency, this is m times frequency, so midpoint by frequency, we get this figure here. 1.75 times that, we get 10.5. 2.25 times that, we get all these figures here. Then when you total up, the summation of the mid frequency is 116. So when you divide that by our n is simply when we sum up these figures here, which is 45. So 116.25 divided by our n, which is 45, we get 2.58 meters. This is the average. So that is the average you can recommend because that is even where the most of the housewives will come from. So the average comes now to 2.58. 6 marks for that. Are we together?
Yes.
All right. So we go to another question, just on statistics, and we'll go to something else. So statistics comes in different ways. So we are told that a company has 4 locations with the ratings, location 1, 2, 3. These locations have no numerical value. They could be A, B, C. And we are told that the ratings on average for the 4 locations are given. So we can call this a midpoint since they are average ratings. They're not your means. So X, value of X, 7.5, 7.8, 8.5, and that. Then for the number of customers, this will be called our frequency. So like we did, we're going to multiply this times the frequency. What do we get? 78 by 117. 7.8 by 117, what do we get?
912.6.
Okay, 912.6. The next one. Quickly calculate each one to pick error so that we move fast.
731. 731.
So this one is 912.6, 731. Then
448. 448.8.
448.8. Then
666.
666. And when you sum up,
So what we're finding?
we're finding this column, we're multiplying column 1 times column 2. Okay, so this we want to calculate the what? The mean. They're asking us to find the total average. So we get the ratings times the frequency. Then this one also has to be totaled up. For n here will be what? And here a summation of fx.
So is it always that when you're asked to calculate the average, it means we have to find the mean?
Exactly. Average and mean is one and the same.
Mhm.
Okay.
The summation is 2758.4.
2758.4.
Yes, please.
And our mean and our frequency.
689.6.
361.
What do you get?
Oh, sorry. 361.
361. So when you divide 361 into that,
1.91.
what do you get?
1.91.
1.91. So that becomes
Not 7.
what?
I also got
7.64.
7.64. This sounds more like what I saw in the marking key. So
Yeah.
all right. So how many marks for this? 3 marks. Anyone behind?
So why didn't we just multiply the total average? What have we done? I'm even getting lost now.
So this we don't need.
Total average, right? Why didn't we just add the average rating, the total of the average ratings, and divide by 4?
Because the formula for the mean is simply summation of fx over n. So this is a mistake most people are making. They average this and divide by the number, and the answer was wrong. So I'm glad you're bringing the possible mistakes that people will make. Others are applying
So
this.
it's summation of x, not summation of x.
It's summation of fx, yes, over because there's a frequency there. Yeah. So that's a mistake most people.
Hi, Collins.
Yes, sir.
Me, I just want just a confirmation. I want to confirm that formula sheet. Do they give in the exam?
Yes, you're given the exam.
Okay, thanks.
All right. So we are now going to calculate. Okay, this question, we'll look at it later on. It was very tricky. Yeah, a few people got it right. We go to some probability. So probability, we were told that in a certain town, we had 50% of the population are male and female. So although the grammar was a little bit confusing for some, but what this means that the population was into half. So we had 50 males, 0.5, and for the females, we had 50, 0.5. Then we are told that it is known that 20% of the males, so coming from the males, so we're what? Unemployed. So unemployed coming from the male. So this must tell you where it is coming from. Unemployed coming from the male was 20%, 0.2. Then also unemployed coming from the females was 5%, 0.05. And before you answer anything, you need to multiply these two automatically to get the intersection of the two. So this one is simply unemployed and they were male. So the common characteristic, when you multiply these two, you get 0.1. And this tree diagram, the female and unemployed given female, when you do this, it will be unemployed intersection what? Female. This one by that one, we get 0.0 0.025. So, according to theorem 2, when you're adding two intersections, for instance, U intersection M plus U intersection F, the sum total will be the common letter. So what letter is common between these two? It's letter U. And U stands for the unemployed. So when you add these two, we're going to get what? 0.10 plus 0.025. What we're going to get here is a probability of what? Of U. So 0.10 over 0.025, we're going to get 0.125. Now, dividing this answer into there, what you're getting is simply the reciprocal of this. So 0.10 divided by 0.125, you're getting 80%. So what you're getting here, 0.8. So to find probability of M given U, is simply when we divide the intersection over the probability of U. So this is simply M intersection U. Since the U is down there, it must also come there, down there. And the opposite. So here we divided 0.010 divided by 0.125 to get 0.8. Then here, the opposite, female given the unemployed, we just get there. Regardless, we can start with M intersection U or U intersection M. It's one and the same thing. But the key thing is if there's U down there, the U must also come down there, which we had as 0.025 divided by 0.125, which is 0.2. Let me repeat this slowly again. So we are taught in a certain city, 50% of the population were male and 50, meaning 50% were female. So this must always add up to 100. And it is known that 20% of the females and 5% are unemployed. Let's go here. Probability of unemployed coming from the female. So you can't put you down there. It will give you an idea of what comes down there. Even if you don't know how to do this, but just know E is coming from there. So unemployed coming from the males, 20%, which is 0.2. And probability of unemployed coming from the females, 0.05. So when you multiply male times this, it will must get an intersection of unemployed and the probability of the male. So this is whenever you're multiplying, we know multiplication goes with what? Intersection. So this will be M intersection U. So this by that we get 0.1. And again, 0.5 times U given F, we're going to get 0.025. So when you add these two, we're going to get 0.125. So if you're asked what proportion was unemployed, so of those that were unemployed that were male, it was 10%. Those that were unemployed female, 2.5%. When you add them collectively, you get 12.5% or 0.125. So this is just a bit of U. According to theorem 2, I gave you an idea to say when you're adding intersections, U intersection M plus U intersection F, you pick the common letter, which is U. So this U stands for the probability of the unemployed, U. Now, when we divide this one, divided by the answer, what you just get is the posterior of this. So M realize you realize a punch. If you don't want to memorize the formulas, you can even forget this. This is simply 0.10 over 0.125. We get 80%. Then sometimes you have U given, F given you. Just divide the answer to Sangha. 0.0125 divided by 0.125. We get what? 0.220%. So these are these were 6 marks. So what's the probability that it was a male? It is 80%. You get your 6 marks. What is the probability that a person was unemployed and found to be female? 0.2%. Be mindful that sometimes it may be tricky. Here he's talking about unemployed, then here we change, you say, what is the probability of those that were what? Employed. So the answer to get is subtract from 1. So if 80% of the males were employed, meaning 20 were unemployed. If 20% of the females were employed, meaning 80 must be unemployed. So take note of the same scenario question. I think Esther Tamenji is the one who had identified this. So I sat down to really look at this. Esther, do you remember this?
Yes, I remember.
Remember, great. Okay, so have I simplified this for you? The TUE diagram, I want you to, you've never learned it like this, but I've simplified it in a way that you can also consider it, because most of you will have the tree, the table. Is this okay?
Yes, yes. No, no, I will go for the table, not the tree diagram.
All right, please go with what you're able to remember. I'll look at the table tomorrow during the day. Any questions so far?
I'll just scroll down a bit. I want to see. Yeah, just there. Okay, thank you.
And possibly selecting certain questions from what you already have. I don't want to be accused of getting questions. This is what you already have. So I'm using your materials. So now let's try to do this together, 3 marks. We're told that the mean observations of 200 observations was 8. It was found that 2 observations were misread as 92 and 8 instead of 192 and 88. So now grammar is very important in this regard. So we can extract the data that we have here. Which one is the mean between 200 and 8? I think people had a problem there.
80.
8 is a what?
The mean.
So 80 is a mean. Then the number of observations n was what?
200.
100. Then it was found that there were 2 observations. All right, we had 92, which was written as what? 192. So it was more by what? 100. We had overstated our figure by 100. And the other one, which was what? 8, it was written as what?
$88.
So we have 2 observations which are misread. 92 and 8. The actual correct figures are supposed to be what? 192 and 88. These ones are the wrong ones that we entered. So in short, here we went over by 100. So we need to do what? To subtract. So we're going to less. Here we went over by 80. Okay, we went under in short. Maybe let me put a correct grammar that you need to understand. We went, we understated our figure by 100 here, and there we understated the figure by 80. So here there's minus 80, and here minus 100. So first of all, we need to conclude basically that we understated our figures collectively. We are understated by 108 collectively. So we need to calculate the sum total and subtract the 180 there. So our summation of x is given by nx. N is 200 observations. Then our mean was 80. So we actually were supposed to get 16,000. So 16,000 we had understated by we shred this instead of that, so we understated by 180. So we subtract the 180 here. Then we divide the same number of observations, which are 200. So we get the correct mean. So our mean, therefore, will be 1600 16,000 minus what? 180. Then divided by 200. We get 79.1. So this 71.1 was if we remove the wrongly added 180. The mean that we are currently showing here is 80 because it had an error where we added 180 wrongly. Have I lost anyone? Are we together?
Yeah, I'm a bit behind. No. Maybe you can try to explain once more.
In short, we had how many observations? We had 200 observations. So x1, x200. Okay, when we added all these, divided by 200, the mean that we got was 8. Now, in these observations, we are told that apparently there were 2 entries that were entered wrongly. One was supposed to be 80, we wrote 8. So meaning we deprived ourselves of how many marks? 80. It was supposed to be 88, we only wrote 8. Are we together on that? Are we together on that? So
which one is x and 2? These ones, the ones you're adding, which ones are they?
the ones we're adding, we're not given, they're just values. I said from x1 up to x200. Maybe there was a 20, 30, 40, they're just numbers. So if we added all the 200 numbers, x1 means the first observations, x200 means the 200th observation. If we add all these figures from x1 to x200, the total divided by 200 was giving us 8. So meaning we want to know what these 200 observations were totaling to. So to know the sum total, just multiply 200 times 80, we got 1,000. 16,000. So meaning whatever figures were in here, when you total them up, they'll give you 1,600. Is that clear? first of all. Huh?
Yes.
We don't need to know
Yes.
what individual figures those are, but we know that when we divide 16,000 divided by 200 to give us 8. Now, after auditing, we discovered that there were two figures in these 200 observations. One, which was supposed to be 192, we actually put a 92, meaning already we lost 100 from there. So, all right.
Yes.
Are we together?
Yes.
Grammar properly there.
Actually, to
We're
only one
told-
topic. So the
So we are told that of these observations, there are two observations which were misread as 192. So instead of writing 192, we wrote what? 92. So what does that mean? Instead of writing 192, we wrote 92. So meaning we understated by what? By 100.
100.
So we need to add our 100 there. Add our 100 there, which we understated on the what? On the 192. Because in here, we wrote 92. And the other figure which we understated was what? 88. We wrote it as what? 8. So on this 8, to correct it, we add the 8 which was missing. Are you together? So that our total figure, instead of 1,600, we're supposed to have 1,600, 16,000 plus 100 plus 8. The total figure is supposed to be 1618. Are we together on this at this point?
Correct.
Then that's when we divide by the same. The number of observations still remain to be 200 because we're just adjusting the two observations, but the total still remains. So when we divide by 200, our answer is supposed to be 80.9. Not the figure we wrote here. Actually, we're supposed to add here. So we're supposed to get 80.9. Is this clear?
Correct.
Yeah. Thank you for that. All right. So statistics is a question 1. So you need to prepare for that. Statistics is question 1. You need to prepare for that. Okay, then probability is coming in 2 questions. So if you're going to avoid it, it depends. Analyze the questions that you have and see which probability to avoid. But the probabilities that are familiar, just memorize with terrible exactness. So a piece of equipment will only function when all the 3 are working. So we are told that the probability that a failing machine, the probability of A failing in 1 year is 0.15. So probability of A failing is 0.15. So meaning probability of A working will what? The complement of A. So A will work at 85%. Then also we are told that the probability that B will fail is 0.05. So the two must add up to 100, the B and its complement. So if B will fail at 0.05, what's the probability that B will work? It is the complement of B. So B working is what? 95% or 0.95. Then the probability of C working is 10%, which is 0.10. So probability of C complement. What is the complement of C? 90%, which is 0.90. Now, what are we doing? We're being asked to find the probability that the machine will fail before the end of the year. Let's read it again. We're told that the probability that a machine will function, we're told that the machine will only function when all the components A, B, and C are working. So the last question is asking us, what is the probability that the machine will fail before the end of the year? So this is the probability of failing. Now I want to mention one critical thing. Ideally, since these are independent events, we're supposed to multiply probability of A failing times probability of B failing times probability of C failing to get the answer directly. But we don't do that. We do the long cut. We first calculate the probability that each of the machines will work.
Sorry to disturb, sir. How do you know if an event is independent and mutual?
Okay. Any other question as well?
I wanted to find out, you mentioned that that if the machine is supposed to work, all the three components must work. Now, we can find the probability they are asking for using the shortcut method, but you have just mentioned that we don't do that. Why not use the shortcut?
That's a very good question. Okay. Any other questions? All right, okay, now let me answer the two questions. Number one, how do we know they're independent? In fact, this statement should have stated that, but of course, the probability that events occur independently usually happens for activities that are stated. So if events 1, 2, and 3, for instance, are a component on an airplane, and one is working, so they usually follow what we call a binomial distribution, which has a success and a failure. So these are assumed to be occurring independently. So they possess a binomial characteristic, which is there. So this question can be done also under binomial, but I don't want to use that method. So assume it's an assumption that we have that these machines operate independently. Secondly, why don't we use a shortcut to just multiply them? We give you a wrong answer. Trying to revert the shortcut, because for these independent events, the procedure is simply as follows, as a standard that I'm giving you. If a machine has three components, A, B, and C, and these machines are failing, machine A is failing at 15%, meaning it's at 85%. Machine B is failing at 5%, meaning it's working well, 95%. Machine C is failing at 10%, meaning it's working well at 90%. So the probability that all three will fail is simply 1 minus the probability that all three will work. So that is the first statement I'm making. All right. So the second statement is to find the probability that all the three will work for independent events. You just multiply them directly. That is why the aspect that you need to assume that the independent works. So if these are independent, just multiply all the three. Okay, 0.85 times 0.95 times 0.90. So this will give you, what is it giving you? To give you 0.7267. So this is the probability that all of them will work. We are sure that all of them work. 72%. So meaning the chance that all of them will not work is subtracting 1 minus, it's like the complement of this, 1 minus 0.72675. So when you subtract the 1 from there, we'll get 0.27. Na papa tai itafyumfikire so ateni fi. Enfin, itafyumfikire fi so ateni fi.
Oh, that's what.
Dying. Okay. So this is failing, working, failing, working, failing, working. Multiply all this, all the three are working. Subtract from 1, all the three are not working. Chapwa. Why will you bother yourself when he mentioned that the questions that are coming already? Okay, we go to some other question that we need to know. We are given a telephone survey that there are how many adults? There are 1,000 adults. So these 1,000 adults were asked about their expenses on management education and relative necessity in form of their financial assistance. So according to the survey, we are told to the respondents were classified as whether the child has is studying a school management in a school management, or whether they thought the loan was a burden on the students, and they were categorized as too high, right amount, too little. So now 1,000. If you want, you can just multiply the percentages on each of them. 0.35 times 1,000, what we get? We get 350. 0.08 times 1,000, what we get? 8. 0.01 times 1,000, what we get? 10. 0.25 times 1,000, what we get? 250. 0.20 times 1,000, what we get? 200. And 0.11 times 1,000, what we get? 110. The first thing when you're given such a thing, you know that it's a contingency table for probability. This is one of the second easiest. So kusangama totals, just find the side totals and the column totals. So 350 plus 250, we get 600. 80 plus 200, we get to 8. 10 plus 110, we get 120. And we have 350 plus 80 plus 10, we get 440. 250 plus 200 plus 110 is equal to 560. So this total figure here, let's take you back to the what? The total that we had as 1,000. At this point, are we all together?
Yes.
Yes.
Then,
yes,
the letters A, B, C, D, E. What is the probability that the respondent is studying management? Management in D. I said, whenever you're asked to find the probability of 3 girls and 7 boys, the probability of picking a girl is 3 out of the total pupils, which is 10, which is 30%. So we know that the total number of adults is what? 1,000. What's the probability of a child studying management? So studying management here, plus to the D, you get the total. What's the total? 440 divided by the total number of students, what? 1000. Okay. So asking you to find the probability of D. Probability of D is simply what? The total number of D elements over the total number of events, the total. So 440 divided by what? 1000. So what we get is 0.44. 2 marks. Probability to 2 in tena. That's where your survival is. Then, given that the respondent is studying memory, Kaidi.
Bomba memory.
Yeah, bomba memory. Okay. So given, gamamuna given. Before the other guys come in. Please inbox me so that I create a schedule for the delicate one. Because once I file BID, so there are people who are coming in the 11th hour. But for this one here, given that the respondent has a child studying management. So apart given that, we can letter A. What is child studying management? It is D. Okay. So we are told, given that a respondent has a child studying management, what is the probability that he or she ranks the loan high? So they're asking you to find the probability of what? Probability of A given D. I repeat, there are certain terms that you need to follow. This question is saying, given that the respondent has a child studying management. So you say, given D, find what? A. Why A? Because A says child studying rating high. If they said, given that the child ranks burden loan too high, would have just done /A there. But here it started by saying, given that the respondent has a child studying management. So you do /D. What is the probability that he or she ranks the loan too high? So A given D. So you go where A and D are meeting. They're meeting at what? At 350. But the total for the guy below, the letter D, what is the total for letter D? 440. And Baninda Nakadatin decimal dying moment. Fimbi, just tell your husband that I'm listening to callings. It's not a boyfriend. Just listen to this video and watch. So 350 divided by 440. 0. What? 0.795. So this is a probability that, given that a child is studying management, what's the probability that he or she ranks the loan too high? In short, they're asking you to find A given D. So whenever you're doing this, you draw a what? A plus or a cross where they're meeting. A and D, where they're meeting 350. But the total for the bottom letter, what letter? A D. The total is what? 440. So you do 350 divided by what? 440. We get 0.795. I don't to teach much here because I'd have given another example which will end up confusing. Let's memorize my figures. I have 0.44, Dorothy, 0.795. Tap. Then they'll ask you, are the events D and A independent? Explain. How many marks are you talking about here? 8 marks. So to know that events are independent, use A and A because I've given you these letters. A given D must be equal to A. You maintain the top guy. If you wanted to have done D given A, you equate to D. But why bother yourself? Because you already have A given D. So step 1, you write the comparison statement. 0.795. Then you compare what is the probability of A? A is 600 over 1000, 0.6. Then what sign do we put there? Are they the same? No, they're not the same. So they're not independent. So for doing conditions, step 1, you state the what condition. Step 2, you compare figures. Step 3, you conclude. These are the statements that we've been talking about. So for independence, we know step 1, we set the condition. How do we know events are independent? A given D must go to A. A given R must go to A. A given whatever letter E must go to A. You maintain the top guy. Step 2, compare the figures. A given D, what was the answer? 0.75. You put it here. Then probability of A, we didn't find it, but it is quick from here. Probability of A, you get the total for A over the grand total. So 600 over 1000 is 0.6. Probability of B, 280 over 1000. Probability of C, 120 over 1000. It flows. D, 440 over 1000. E, 560 over 1000. But you're interested in the probability of A. It is 600 over 1000, which is 0.6. So step 2, compare the figures. Step 3, after comparing the figures, are they the same? If they're not the same, we conclude that they're what? They're not independent. All right. You conclude that they are not independent. Okay.
The question.
Yes, sir.
Is it okay to use probability of D intersection D? Probability of D intersection A is equal to probability of D times probability of A to prove independence.
Exactly. That's the same. You can compare that. Yeah. It's the same. I'm glad you've been studying. I'm trying to pick out the simplest possible, especially for the extreme B ideas. You're as good as writing tomorrow. So let me go to something else for others who have specialized in something else. All right. So lastly, on probability, you'll be given the probability, the values of X and the probability. This is the easiest probability, by the way. For this one, now I'm 246. And you're given the probability as 0.2, 0.5, and 0.3. They'll ask you to find 3 things. Okay. Find the mean, just multiply these two, X times the probability of X. So 0.2 times 2 is 0.4. 2 times that one is 2.0. 6 times 0.3 is 1.8. The total here is 4.2. That is what you find as a mean. Remember, mean, sometimes they'll ask you to find letter E and an X. This is not summation of X. This is a shortcut for mean. You won't be confused. And to make matters worse, others overthink. They think you're summing up this column. Okay. This is summation of X, and moreover, summation of X is never valid when you're getting the search group unless you're doing the other thing. So the mean will come in 3 ways. It will come as E and X. It will come as mu like this, or summation of X px. We just multiply what we multiplied here. So 4.2 is our mean. Then how to find the standard deviation? Just square your x values there. Our x values here we have 4. Here we have a 16. Here we have a what? 36. Don't sum anything up. So you multiply 4 times 0.2. We get a summation of x squared px. So 4 times 0.4, 1.6. 16 times this, 3.2. No, what am I multiplying? It's supposed to be x squared times the probability, not with these figures there. What was writing here? 4 times 0.2. What do we get? 0.8. 16 times 0.5. What do we get? 8.0. Then 36 times 0.3. What do we get? 10.8. So when we add these, here we get 16, carry 1. Here we have 9 and 1. So this is not a variance. The variance is simply this one. So the variance of x. Mean formula. This mean is for what? For statistics. Here, under probability, this mean does not hold. A variance, like what a formula, which we use summation of x squared px times the mean that you just calculated. Summation of x px to the power 2. So here we have 19.6 minus 4.2 squared. So what you get is what? Minus 4.2 squared, 1.96. This is a variance. You get your 2 marks. Then they'll ask you for standard deviation. Standard deviation is always the square root of the variance. 1.96. Square root of 1.96 will give you 1.4. So this is another 2 marks. 2 marks, 2 marks, and 2 marks. Are we together? Anyone behind? Okay. So we can now go to an exam question. Then we go to ANOVA regression. So by the time we're done with this, you're able to sort out an exam question. So just this here, he brought a question on that type. And it came in this form. This question was exactly from our QM Bible. And you ask, calculate the mean, calculate the standard deviation. So standard deviation had more marks because you also have to find the variance. Okay, before getting standard deviation inevitable. So Kaisaka quickly, Kumbarioku, Pamari, to avoid confusion, just square them. This is 1, this is 4, this is 9, this is 16, this is 25, and this is 36. Then you multiply this by that, 0.12. Okay, this is x px. 2 times that one, 0.3, 3 times that one, until you finish all of them. You will discover that your mean 3.7. Two marks. Can you feel? Do we need to do it completely, or you get the concept?
I think we've gotten the concept.
Okay, so we've gotten the concept, right?
Yes.
All right. So more other folks to memorize, please. Mean yara 3.7, but to get the concept and find the answer. Fine. All right. So we go to another simple probability question. We're given our exam sheet to say that each semester for you to get a final score, we had the following grade computation for an exam.
The previous one, we have to master the formula. It's not given.
Yes, it is not given for this one, yes.
Oh.
It's given, it's there, it's given. Yeah.
Yeah. Oh.
It's given. So here we're told that assume students' final statistics grade for the semester is based on a combination of the final exam score, the project score, and the homework score. Each is weighted in the table below. Calculate the final grade, a student with exam score 94, homework score 89, and a project score 89 and homework score 83. Find the grade for marks. First of all, we need to find these weights, and we add them up. 50 plus 35 plus 15, we get 100. Fortunately, sometimes it's 80, but this one was easy because then you get the weight. What is the weight of this one? 100 divided by 50, 0.5. 30 divided by 50, 0.35. 15 divided by 100, 0.15. Then we put the actual mark. So we're told that the grade that we had here, we get the score. So the score that we have here, we have 0.5 times the exam was what? 94. So 0.5 times 94, 0.5 times 94, we get what? 47. So you put your 47 there. In actual sense, this is how your CAs are done. Or your mark allocation for the final exam. You get your 47, then 0.35 for the project against what? 89. So we get point what? 0.35 times 89. We're going to get what? 31.15. Then 0.15 times 83. You get 24 point or 12.45. Then we add all the scores plus 31.15 plus 47.
Mr. Collins, how are you getting these figures on the S?
The score, can somebody explain?
We are multiplying the weights and the results. So in the question there, we have got, is it 94, 89, and the 83? So we are multiplying with the weights.
So we are locating each of these ones here. So 94 goes to the exam. But we cannot multiply this one directly. We get the exam, the score. All right. So 94 will be multiplied by what? If you want to multiply them directly, 50 divided by 100. This will give you 47. That is for the exam. The project, you got what? 89. So to 89 times what? 85 over 100. Will give us what? Will give us that 1.15. And finally, the homework. What did we get? 83. 83 times 15 over 100. It will give us what? 12.45. So now to get the final grade, we add all these three, it will give us 90 point what? 90.6. Are we together now? So if the total is adding up to 80, we have done 50 out of 8, 35 out of 8, 50 out of 8. Okay. So 4 marks. Are we moving? We go to estimation. So we need to understand that sampling involves collecting subunits from an entire census. So these sampling procedures come into two categories. We have what we call the probability and the non-probability sampling procedures. So under probability sampling methods, we have what we call the simple random sampling method. We also have what we call the systematic sampling method. We also have what we call the cluster, and also we have what we call the stratified. So we need to understand what each of these ones entail briefly, and also maybe give an example where possible. So we start with a simple random sampling. What is a simple random sampling? And what examples can we give? When I'm dealing with simple random sampling, we're simply talking of a procedure that involves us selecting a sample subset from the larger census randomly using the same probability. So simple random sampling is a simple type of probability where the researcher will select what? A subset of the participants from the whole population with equal chance. So that is the distinctive characteristic. In a layman's language, it's simply collecting sampling or participants of the population using an equal probability. All right. Then when we go to another kind of sampling, which is called systematic sampling, it's a type of probability method which simply involves sample members from a larger population being selected to a random point with a fixed periodic interval. Here, the key term is a periodic interval. An example that I've always given is tithe. Tithe has an interval of every 10th. So there's a fixed periodic interval that we use. Are we together? So we got to a cluster sampling. Cluster sampling is a probability method where you are going to divide your population into clusters. These clusters may have distinctive characteristics. For instance, we are divided into programs, MBA General, MBA Finance, and after you group them there into these classes that have a similar characteristic, then you randomly select them into the mini representations. So you first group them into clusters such as schools, programs, districts, then you randomly select them from the clusters. Are we together? Then we have what we call stratified sampling. Stratified sampling is similar to cluster. Here we are going to subdivide the entire population into smaller groups, which are called strata. Then from them, we are going to collect respondents. So the entire population, you subdivide it into smaller groups, which are called strata. And that process is called stratification, of course. So this is to highlight the differences that are distinctive between the groups. For instance, top management, middle management, you put them into these groups called strata. So once you do that, you now collect respondents from those subgroups. So this is a method which usually ensures that the subgroup receives proper representation. Unlike as random sampling, for instance, where the whole population, you're randomly selecting them, you all select all of them from low management. So representation may not really be even at the criteria because you have no representation. For instance, sometimes you pick all males, but it was simple random, but there are no female representation. So strata or stratified sampling will ensure that there's equal representation from the groups. It gives a better coverage and control than simple random. So we are also asked to identify the implications of central limit theorem. Implications of the central limit theorem on sampling. Can somebody answer that? What is the implication of central limit theorem on a sampling? To start with, the central limit theorem stipulates that the sampling distribution of the mean will always be normally distributed as long as we have a sample size that is large enough, regardless of the population, whether it is in a Poisson, in a normal, in a binomial, or other sampling distribution. So the central limit theorem helps us identify where the mean will lie. So if the mean is identified, it will be able to give us our three key parameters. Standard deviation is based on the mean. Coefficient of skewness is based on the mean. We'll be able to tell whether it is skewed to the left or skewed to the right. All right, so
just come again on the central limit theorem. Just come again.
So I began by first stating that the central limit theorem gives you an idea whether you have a sufficiently, the central limit theorem gives you the parameters upon which the sampling distribution will be selected. So it's able to help you calculate the statistical parameters like the mean, the standard deviation, the variance. So using this theorem, we are able to identify the distribution of your sampling units as to whether they are skewed to the left, skewed to the right, the deviations from each other are vast or minimal. So the central theorem actually stipulates that the sampling distribution of the mean will always be normally distributed as long as you have a sample size which is large enough. So regardless of whether the population you're dealing with is a normal, it is a binomial, it's a Poisson, or whether the population is of any other distribution, the sampling distribution of the mean will always be normal. So with the assumption that I've just mentioned, we always assume that the normal distribution is asymmetrical. It is bell-shaped. It is increasingly fewer as you move further from the central center distribution. So it gives us the characteristics of the normal distribution. So we assume that the mean is always in the middle here. It is bell-shaped. It is also increasing. The standard deviation, as you go up, you have two standard, Chebyshev rule, this is where it comes from. Three standard deviations, 2 STs, and 1 ST. So 3 standard deviation, 2 standard deviation, 1. Who remembers the formula for Chebyshev's rule? 1 minus what? 1 over k squared. So regardless of which population, it's able to tell you how many standard deviations are there. If you are being asked within 3 standard deviations, 1 minus 1 over 3 squared. 2 standard deviations, 1 minus 1 over 2 squared. Okay. So, etc. So now I'm interested in now explaining to you, as obviously deviating briefly, what the gentleman was asking for regarding us calculating our confidence intervals. Okay. So when dealing with normal distribution, you need to understand that Z is given by mean minus mu over standard deviation, or Z is equal to mean minus mu over standard deviation square root of n, where the standard error is simply standard deviation over square root of n, meaning our Z is equal to mean minus mu over the standard error. So I've basically gathered up what I'm calling a miracle question bank, where I've gathered some questions within the 4 topics. Of course, those who reserved for the copy and paid, let me finish it up because some questions that I've left behind. I will know how to cover you in, but I tried to simplify what I could. So these questions that I've put are just from the normal papers we've done, the test, but just according to my own criteria, what I feel may come. But the key issue is you understanding what is there. You may have a question bank because you only have a night before you write. So you need to understand concepts in there. So we are told to assume that systolic blood pressure of a 30-year-old male is normally distributed with the mean of 122 and standard deviation is 10. All right, so what are we given here? The 30 is just the years, don't use that. Normally distributed, we're told that we're using normal distribution. So given our X or our mu as 122, mu is 122. The standard deviation is 10. So ST is 10. So we're being asked a random sample of 16 men from this age group were selected. So our N is what? 16. Calculate the probability that the blood pressure will be greater than 125. So X is greater than 125. So I gave you the 5-point procedure of dealing with normal distribution. Normal distribution is a most cardinal distribution of them all because it carries more marks. I said step 1, we use the word what? ISA. Step 1, illustrate. Step 2, shade. Step 3, standardize. And step 4, apply. Like I said, at this point, I'm not teaching. I've done much of the teaching. Only for the few of you, I think I'm already familiar with. We met yesterday, so please come early tomorrow. All right. So what are we doing? We want to, let's give me what has been given there. So we've been given our what? Our mu 122 and our SD is 10. So mu is always in the middle, like we made the assumption, the mean is always in the middle, 122. Our standard deviation is 10. Part A of the question, carrying how many marks? Carrying 3 marks. Find the probability that it's greater than 125. So identify where the 125 is. It's here. So it says greater than 125. So the sign greater means shade to the right. So step 2 says shade. So 125 is here. We're going to shade this direction. In step 2, we have done. Step 1, we have done. Now step 3, standardize. So this, we need to standardize it. We only use formula when you're given n. If you're not given n, you use this formula here. This one, given n. So in this case, we're going to standardize. This is 125 minus 122 over standard deviation, which is 10. And our n was given, in this case, as what? Given our n as 16 men. So square root of 16. So 4, 2.5, and 125 minus 122, we get what? 3. 3 divided by 2.5. Divide that. We get our Z value. $1.2. All right. So after you get the 1.2, we now go to the statistical tables. And in statistical tables, I pleaded with you that you need to acquaint yourselves with the one questions they brought. I'll able tomorrow to teach you how to use these tables, but 1.2 is here. So this is 0.3849. 0.3849. So others I use the cumulative table, others I use with the non-cumulative table. The one who has a full copy of the previous exam papers, you should come and verify which table you use. But this one is a half table or a 0.5 table. Whenever we're dealing with the 0.5 table and the reading is smaller than 50, we subtract from 0.5. So to get this reading, we're going to do 1 minus the reading we found there. What was the reading again? 1.2, 3849. So 3849 simply means our reading is from where? Here to here, 3849. So the shaded region will therefore be 0.5 minus what? At 8, 9. So 0.5 minus 38, 49. Get 0.1151. So if they told you from the probability that it's less than 125, would have just shaded this other side, and the answer would have added to 0.5 because this is the 8% and this is an obvious 50%. So would have added 0. What? That 849 plus 0.50. So we get the final answer as 8849. Okay. So for those of you in BIT, I explained to say, listen to my videos before you come to class at Fiango Keko. I don't want to stress you with probability tomorrow, ANOVA, regression, hypothesis testing, statistics. Stop. Tomorrow it's still you drop from is it from 11 to 18.
Now it's 18. 10 to 18.
No. I think because I need to create time for the weaker guys, so that I can say 9 to 11. I meet them up.
What time are you putting the weaker guys?
9 to 11. Okay, we'll find them, we'll join them.
No.
So that
I'm not meeting them from here. I'll inbox them because if I say here, everyone will come.
But we're all weak. We're all weak, we'll find them.
And today are firing us shots, so you've just weakened us.
No, I'm trying to be blunt. I want 100% passing here. So I don't want to make it look easy, but I want to also touch the relevant stuff. But also for your own sake, if I meet the weak ones alone, as they join us, it'll be easy. It'll be less burdensome also on you because we may end up doing one question the whole day. So it's better they're taken through these small things.
Okay, okay.
Sorry, what did you just say?
I'm saying the weak ones, I will take them through separately, just that they reach a certain level with examples that are easy for them to understand. Then that's when they'll join you, so they understand what you are talking about. All right, so
This will
so 9 to 11. Let me meet those only on invitation. I will tell if you don't receive my text, please don't inbox me to be invited. I'll invite you myself. Okay.
So if you're inviting us yourself, how will you know that this is a weaker person?
I know you. I've always met you people, so I know who's weak. So once you don't receive my text, then you're not invited for the weak group. Okay. All right. So I think I'll end here for now. Unless there's anything you need to ask.
Yeah, I have a question. What if we have friends that are weak? How can they reach you? Can they call you?
The unfortunate part with them, they're paying the same amount that the rest of you guys are paying. So let them join the weak guys.
Oh.
Yes. So it's a reason why I give an advantage for people to start early. It's far cheaper if you pay early. You don't pay any of these last minute stuff. And also, I plead with all of you to come for the dinner. Dinner is not only about feasting. We want to prepare you in advance for the next level. We are starting classes. This issue, last minute classes, we don't want it to. It's stressful, not only on us. So others will start before the exams. I can tell the other people who I'm sure are going to clear this course and the other courses. For the others, who are too new for me to tell their weaknesses. I can't. But others who are extreme BID, I'll tell you to say, you are beyond redemption, my friend. Please go to somebody else. But those that I've started with specifically, I don't want, that's why I need to quarantine you, because this particular intake, none of you I'm seeing is failing, unless you just want to. So Friday, after Mwale and Bama papers, and come for the so you know who will be meeting in the second level. We are here up until your graduation. And not only that, we are going to take you through analysis, who we expect in this course and what they require. The difference between us, my team, and other tutors who just come in, they don't know the lecturer, they think they know the stuff, but you need to know what the lecturer wants. All right. Then those that are coming tomorrow, please carry packed lunch or come, because it's limited. Those ones that have been regular, be there, because our slots here, we don't want to overcrowd the sitting arrangement. If they're more than necessarily, I know the others who haven't been attending, but they're already paid up. I need to know it, because we may end up changing the venue, or that I may expect an over enrollment tomorrow. So today I would have been tired. That's why I didn't have class physically. Tomorrow is a very critical day. So Napapata, if you're studying, go to study from the 10th. If you're not invited, don't come the 9 to 11. All right. Then I'm supposed to meet those who got the miracle pamphlet. I'll send you a link at 22. We are meeting. Let's just go through a few questions. But your copy, like I said, I'm still adding a few things. I'll send it first thing in the morning or by 5. So go through that. But I'm supposed to take you through also in that document as well at 22 and early in the morning, maybe at 6. So we go through those few topics. But some of the topics that I said, I've already covered them with the other people. I just want you to understand it's the pool of questions that we are using. I'm not getting any foreign materials. It's your past papers. So if you see the exact questions in there, I'm just showing you what is actually what was done in previous papers, your tests especially. But of course, not all the questions in your tests and other questions in your assignments are coming. You need to know what to choose and pick. So I've done a few questions. I'll send you through. In case I forget and you made a payment for them today, just inbox me. I'll send through. Otherwise, I'll be meeting you at 22. Those, before I close up, can I do another question or we'll leave the rest tomorrow? I still have, I think 20 minutes.
Is it possible to go through that one for failing, probability of A failing, probability?
That one, you can check the video. I can do it again tomorrow, but I'd rather give.
Or sending the video, fine.
Yes, I'll send the video.
You know?
Yes, I'll send it in the group. All right, so yeah.
Promissory note for the 350s. We are broke, Mr. Collins. Some of us.
Inbox me for that, but I've generally covered almost everything that you need to know. The other things you need to create time for yourself as well. Yeah. All right. Okay. So I have another class. End here. Have a good evening.
Oh.